We typically think of geometry as a course about shapes. That's true. But in high school geometry, we have another agenda, which is to teach logic and reasoning. So in this course, we start from the very beginning and we develop this field of mathematics. Okay, now we're actually going to start with three basic items. They're going to be called points, lines, and planes. Okay, and we're going to use those shapes to start to develop other shapes. And little by little, we eventually prove properties about those shapes, and that becomes geometry. A point, which we can see here, this is point A, has no dimension. It is just simply a location. Okay, and what that means is that you can't measure it. There's no size to it. There's no way to quantify it. It's just, where is it located? Sometimes it's at the intersection of two lines. Sometimes it's at a vertex of like a cube or some other solid. It's just a location that we can identify. All right, a line does have one dimension. That dimension is called length. Okay, now I want to be real clear here though when I talk about length, because the length of a line, that's the dimension that it has, but it is not a measurable length. There's a different shape that we're going to talk about in a little bit, which is called a segment. A segment is a measurable part of a line. Okay, so here we're just talking about that it at least has a dimension where the point had nothing. This is a picture of a line. One of the most important things that you're going to see with lines and diagrams is that they have these little arrowheads on the end of them. Okay, it indicates that the line is going to go on forever. It's going to extend in both directions forever. All right, now there's three different ways that we can name this line. The first starts with this little letter L here. That's a script letter L. At the end of a line, you can just give it a name by writing a lowercase script letter there. In this case, it's L. And sometimes that's useful for diagrams where there's a lot of lines in it. You can easily identify what line we're supposed to be looking at. So you can do that. Alternatively, you can use points that would be on the line. For example, this line, line L, actually has points A and B on it. Okay, so if you want to, you can choose 2 points that would be on the line, and you can use those to make a name. Okay, so what we have down here, you can write it as line L, using that script L that we got, or you can call it line AB. You can also call it line BA. Now, one other choice that we have that we would like to use a lot is you can use symbols. Okay, instead of writing the word line, then AB, you can just take AB and then draw what looks like a picture of a line above it. It's a little bar with arrowheads on it, and that you would just read as line AB. Okay, and again, you can do the same thing here. You can do BA and then draw that symbol on top of that, and that you just read as line BA. A plane has two dimensions. It has a length and a width. And like when I talked about the line, want to be real careful here that we're not thinking length and width as things that we can measure and quantify. Okay, when we draw a picture of a plane, we do draw it to look like a parallelogram or a rhombus. We're going to draw it to look like a shape because it gives us a nice concept of this three-dimensional space that all these things are in there. So there's a little bit of a tilt to it, gives you some depth to it. But in reality, the one thing that we really need to know, and I think this is a tough one to get across, is that when we draw it with these lines here, that's just to give us something to look at. The truth is that the plane goes on forever. There is no boundary here. It just keeps going out. There isn't a boundary over here on the right. It just keeps going out. And it even goes out past that corner. Okay, so when you have something like this shape versus a line that goes on forever, there really isn't like any way that you can draw it with some arrowheads on it that indicate it's going to go further out. So we actually just bound it off as a parallelogram. But remember, these are not edges. These are not corners. Okay, this is not a contained region of space here. All right, naming it, you have a couple of different choices. You can name it using one letter, but it would have to be a very particular letter. So this is plain M. What you're going to notice is that M is first, it's sort of pushed over here into the corner. That's one thing that we'll notice about it. Second, maybe more important here, is that it doesn't have a dot next to it. See, A, B, and C, these are points that sit on the plane. Those are locations on the plane, and then M, not having a dot, is indicating that that would be a name for that shape. Another couple things about it, just in case you see this in a textbook, we tend to print that in a bold font versus the fonts that we have here. Now, when you're drawing things, you're not really going to be able to make something a bold font. So the main identifiable thing will be is that it does not have a point. But also go ahead and make sure that if you're going to label it, that you tuck it into a corner. That'd be a good idea. All right, so you can call it plain M, just using that if that name is available. The other approach that you could use is to take 3 points that would be on the plane. You do have to have 3 points. You do also have to have 3 points that are not in a straight line with each other. As long as they would connect to make a triangle, you could use those 3 points to name it, and we can call this plane ABC. Example number 1 has a diagram of a bunch of points, a couple of lines, and a parallelogram. And what we're going to do is answer a few questions about them. A couple of these are going to introduce 2 new vocabulary words, which is collinear and coplanar. All right, let's talk about the picture first for just a quick bit here. The plane has a lot of points on it, and you can use any 3 points that you want to name it, except for the 3 that are in a straight line, which we'll address a little bit later on. You also have this capital R that's in the corner here, and that's in that sort of bold font. It doesn't have a dot next to it, which means that this plane could also be called R. That's what that is for there. So don't treat that one as a point. That is the name of the plane. Likewise, the lines that we have here, to the ends of those, we have lowercase n and m. Those are in a script font. It's a little bit hard to tell that, but they're supposed to be in a script font, and you can use those as ways to identify which of the lines that you're talking about. But then you could also use a couple of points if you wanted. All right, and that actually gets us into the first question. Give 2 other names for line, right? You're going to read that as line PQ. All right, so we're going to go look for PQ. Here's point P, here's point Q. So we're talking about that line there. And as I had mentioned just a moment ago, you can actually refer to that as line N. So one of the names is line N. The other way that you could name it is just to switch the order of the letters. So you can do line N, and then you can also do line, that would be with the symbols here, line QP, you can call it that. All right, next. Name 3 points that are collinear. New term here, name 3 points that are collinear. Co means together, and then linear is going to refer to line. So we're looking for 3 points that are sitting in the same line. Okay, now if we look at line N, the only points that we had on it were Q and P, so that's not the one that we're looking at. But if you look at line M, you've got 3 points that are identified here, which is S, P, and T. All right, so the 3 points would be S, P, and T. All right, coplanar, any 3 points can be used to make a plane, so that isn't interesting. But if you can identify 4 points or more, that would be coplanar. That becomes interesting. So you're automatically going to have 3 points on any plane. It takes 3 points to actually create a plane. So if you can identify 4 that are on there, that's a little bit more unique. The 3 points that we used above, S, P, and T, those will be 3 of them that we'll use, and then we're also going to be using point V. Another thing that's interesting about S, P, and T is those points are all collinear, right? They're all part of line M, which means that line M technically sits inside of the plane. That's how we describe it. We say that line M is in the plane, or you can say that it lies on the plane. There's a couple different ways I guess you can actually say it. So it's in the plane or it lies on the plane. Whereas line N is not on the plane, but it does intersect the plane at a single point, which is P. Now that we have a general understanding of points, lines, and planes, what we can do is take those 3 items and start to create new shapes. We can define new items using the things that we had. So up first we have a segment. A segment is a finite piece of a line, right? A line is going to go on forever. But if you were to cut off the line, like just break it so that it does not extend in the 2 different directions, you actually have a finite piece of the line. And that line is going to have what we call endpoints. The endpoints are going to be clearly identified as some points. You're going to give them names if they don't already have them. So you're going to have maybe endpoint A. You're also going to have endpoint B. Again, these are going to be capital letters because they are points. Now, the way that you can name a segment, sort of like how you would name a line, you're going to take the 2 points that you do have, so you can do A and B, and you're going to put a bar over that. So the difference with that and a line is it doesn't have the arrows on the end of it. So this would be read as line segment AB. Now, line segment AB is the exact same thing as line segment BA. The letters just simply tell us that these are the 2 points that we would be connecting together. So the order is important with that. Our second new shape that we're going to get to talk about here is a ray. A ray is a combination of a line and a segment. So it has one endpoint, which means that it's a well-defined stopping point on that, but the other end is going to be like the line where it goes on forever in that direction. The pictures that we have here, there's actually 2 of them. They both have letters A and B, but the difference between the 2 of these is that in the first picture, A is going to be the endpoint, and then B is going to be the endpoint in the second one here. Okay, so the first ray, you could describe it as starting at A, and then it travels to the right forever. It goes through B and then continues on that direction, which does mean that this is not a measurable piece. That was something unique to the segment, which is you can measure it. The other one is going to start at B, and then it's going to go to the left forever, passing through A. All right, now when you name the rays, this is super important that you do them in the right order. Okay, the first picture, that one you have to start with the letter A. Okay, you're going to have AB. You have to start with the endpoint, and then above that, you get to draw a picture of a ray. So you can see you don't have an arrowhead over the A. That means that that's the endpoint, and it tells us that our ray is going to start at A, and it's going to head in the direction of B. It's going to pass through B, and it's going to go on forever. Now, if you switch the order of those letters, you do BA, you start with B, that actually tells you something different. It tells you that you start with B, and then you're going to travel in the direction of A forever, which is this picture. And these are not the same rays. You can even maybe imagine that A and B were the same points, that this ray was on top of that one. Okay, so the first would start at A and then goes to the right forever, and then the other one would start at B and go to the left forever. So they're actually different. Now, one more observation about this. The first picture seems to match the way that we name it, the way that we use the symbols perfect, because the arrow is pointing to the right. The other one is actually pointing in the opposite direction, right? I draw this to the right, even though the diagram is going to the left. Okay, the rule is, and just simply put here, the rule is that you're going to start with the endpoint, and then you're going to use the second letter to give you direction, because you're not always going to have horizontal rays. If it goes to the right, great. If it goes to the left, all right. But what happens if you have a ray that points up or points at a diagonal? We have to have some consistency in how we name it, and the way we do that is to start with the endpoint and then use another point that gives the direction. All right, and that other point can be anything that would be along the ray. It doesn't have to actually be a particular point that was given to you. It could be anything that was on here, just to make sure that you're going in the right direction. Example number 2 is going to allow us to look a little bit closer at segments and rays. What we have is a picture of 2 lines that are intersecting with each other, and 4 points have been identified with little dots. We got E, F, G, and H. They went ahead and put dots on those. J is also a point. It's going to be the point of intersection between those 2 lines. So for that, you don't need to put a little dot on there. That would just be a little bit overkill, and we interpret that the point of intersection is J. All right, first problem, give one other name for line segment GH. All right, so here is GH. We got a little line segment there. That means that the endpoints are defined as G and also H. So your alternative way of writing that one would be HG. And that would be the only way that you could do that. Okay, so you're gonna notice that point J is on that segment. You can't use J as one of the points that you're gonna use to name it, because J is not an endpoint. It actually has to be the endpoints. So for segments, you get 2 different ways that you could name them. Next question, name all the rays with endpoint J, and which of these are opposite rays? All right, so to have a ray, then you've got to have an endpoint, which in this case, it says it wants to be J, and then you just have a direction that you can go. So if you start at J, look at this almost like a street intersection. If you start at J, you can go in that direction, you can go this direction, you could go that way, and you can also go that direction. All right, so let's go ahead and answer these as opposites. Let's suppose that we do this one first. We go from J to E. So we've got ray JE. That I'll just put and here for opposite. All right, that is going to be the opposite of J to F. Those would be opposite rays. We also have JG. That will be the opposite of JH. These are opposite rays. Now, to be real clear here, or try to be real clear with this, opposite rays are going to be rays that go in opposite directions. That's all that means, is that they go in opposite directions. Now, these examples, they use the exact same endpoints with each other. Let's take a look at the first two here, JE and JF. They both start at J and they go in opposite directions. Okay, but the only part that contributes to these being as opposite rays is the fact that they go in opposite directions. So if I have ray JE, and opposite to that is also going to be EJ. So they can have some overlap. You can even have maybe some spacing between them. As long as they go in opposite directions, they will be considered as opposite rays. All right, third question, are HJ and JH the same ray? You should be able to answer that question, whether or not they are the same ray. You should be able to answer that question without even looking at the picture, because when you write the name to the rays, you have to start with the endpoints, and then the second letter gives you the direction that you're going to go in. So if this starts at H, this starts at J, they can't be the same ray, okay? Now, being that the letters are flip-flop, that is actually going to be opposite rays, which is what I was trying to describe here with JE and JF, that they don't have to start at the same point as long as they're in opposite directions. That'd be fine, and that's what happens here. So you'd have H start here at H, heading in the direction of J forever. The other starting at J and heading in the direction that way forever. So those would be considered opposite rays. Got that word on there, opposite rays. All right, HJ, which we just looked at here, start at H and head in the direction of J. And HG and HG, are they the same ray? The answer to that one is yes. Okay, first off, they do have the same endpoint. They start at the same place. So as long as J and G are collinear with H, then it's the same ray. We're just choosing to use a different point to indicate the direction. Okay, so if you go H through J, that's that direction, then the other one is H through G, which is still the same thing. Remember that it goes on forever, so it doesn't matter what letter you're going to use for the direction, it just indicates where you're going, which is what we wanted. Last, what we're going to talk about in this video is intersections. You can have lines intersecting with each other. You can also have planes intersecting with each other. You can even have a line intersecting with a plane. And it's important that we know what it looks like when they intersect. Now, the first I think is pretty easy, and most of us would accept this as like it's truth and we get it. Okay, if you have a couple lines that intersect, if they intersect, because remember, if lines are parallel, they do not intersect. If they do intersect, you're going to get a point. It's a single location where they are like sharing space. Okay, so lines are going to intersect at a point. The tricky one here is going to be planes. Okay, when planes intersect with each other, they're going to create lines. Now, this is a pretty good picture of one here because you actually get to see the two planes. They appear to be maybe perpendicular to each other, and you've got that, well, it's line Q there that you could see. The part that gets a bit tricky is you need to remember that planes extend on forever. So if you needed to draw a picture of a couple of planes intersecting, you have to keep in mind that they don't have edges on them, and they definitely don't have like little corners. So you can't take two planes and just like match up two corners together and say that they intersect at a point. That isn't true. When the planes extend out forever as they should, they eventually create lines that look like this. All right, example number 3. What we're going to attempt to do here is sketch some pictures of planes and lines as they fit these descriptions. All right, so the first says that we're going to sketch a plane, already done, and a line that is in the plane. What that means, to say that it is in the plane, that means that every single point that would be on that line is also part of the plane. You can also describe it as just being on top of the plane. So it's literally sitting right on top of it. Sometimes in the pictures, you're gonna have to use a little bit of imagination to make sure you understand what it is, but I think that one came out pretty good here. the line is sitting on top of the plane. So you could almost think of the plane as a tabletop, and we just have a little stick on there we drew on top of the tabletop. The second picture, we got our plane, and we're gonna draw a line that does not intersect the plane. So the only way that our line cannot intersect the plane is if it floats above it, right? And it's gonna float above it or maybe below it. It's either gonna be above or below, not next to, because the plane goes on forever. Okay, it's either gonna float above or below it, and it's not gonna have a tilt that will eventually bring it into the plane. So what we're looking at for that, is a line that would be parallel. So somewhere above it, probably a good place. You could do it on the bottom side of the plane as well, but probably easier to draw it above. And again, this takes a bit of imagination to accept what we're doing here, but we're trying to show that there's a plane that's extending out, and then that line just floats above it, running parallel. If it tilts at all, eventually it runs into the plane, which is what the last one's going to cover. We want our line to intersect the plane at a single point. So, yeah, if that were to tilt, eventually it will run into the plane. So what we're going to do is make sure that our line actually goes through it. And you can do this at whatever angle you want. Perpendicular looks pretty good, but you could also maybe hit this at some sort of an angle. Okay, so we'll do that. And probably should have done this part at the same time, but then show that it extends out of the bottom there. And then this would be the point of contact there.
Later, blah.